This graph allows us to use a few principles to sketch the inverse of a circular trigonometric function. So we're going to start with sine of x. Now we know sine of x looks like this. And it continues on the other side as well. So sine looks like that. Now, we're going to consider a few principles here to help us sketch. We know that if I have a function n and it equals 0, we know that 1 over n will equal infinity. And that's going to give us an asymptote. So that means for our cosec, remembering cosec equals 1 over sine of x. That's an important piece of information we need to include. Now I know that any time that sine of x equals 0, cosec is going to have an asymptote. So I'm going to draw my asymptotes in. And you can see here there's quite a few of them. Oops, that's a little bit wonky. Let's straighten that one up a tad. So here are some asymptotes that we'll have in. Of course, you'll rule them. I'm working freehand. Now, we have another piece of information we know, and that is that when n has a local minimum, 1 over n has a local maximum. And when n has a local maximum, 1 over n has a local minimum as well. And we'll be using that. So for all of these maximums here, my 1 over n, my reciprocal graph, will have a local minimum. And for all these minima, my reciprocal graph will have a maximum. Another important piece of information here is we know that the minimum and the maximum of a sine graph is 1 and -1, or -1 and 1 respectively. And we also know that when n equals 1, my reciprocal of that is also 1. And when a denominator, here the whole time I'm talking about this idea of n, I'm talking about a denominator. And when a denominator is -1, then my reciprocal of that is also -1. Which means in this special case, we're going to have points of intersection between the sine graph and the cosec graph. So what's going to happen here when I put all of these into play is I have a small negative number here, which means my cosec graph is going to have a large negative number. They're going to intersect when the y value is -1. And then as my sine graph gets closer to 0, my cosec is going to become a larger and larger negative number. Then in this next segment here, you'll find it's a similar shape, but it's above. And again, they'll intersect when the y value is 1. And we'll keep repeating here. They intersect there. They'll intersect there. There. And there, and so on. So the graph of cosec x actually looks like this. You'll see it has asymptotes when, in this case, at pi, 2 pi, and so on, every time sine equals 0. And it has maxima and minima at the pi on 2's and 3 pi on 2's when sine reaches its maximum and minimum. If you found this video helpful, please subscribe or like. Thanks.